Beginning with translations, we have the x and y axis. Start with the x-axis. Basically, translate with the x-axis only, or the x variable only. So you get hy equals to gx plus minus k, or y equals to fx plus minus k. Idea of opposite. So translate k units in the negative for x plus k, positive for x minus k in the x direction. Alright, so in positive or negative x direction. Similarly for y-axis, only affect the y variable, so hy plus minus k or y plus minus k. Of course, if you get y plus minus k, you can change it to y equals to fx minus plus k. Same idea, translate k units in the negative or positive y direction. Again, negative for y plus k, positive for y minus k. Of course, if you look at y equals to fx minus plus k, you can write it as y equals to fx plus minus k. Essentially, the plus minus k is how your y value will change. Plus k, you move up. Minus k, you move down. Moving on to scaling, we basically multiply a variable by a constant. Hy equals to gkx or y equals to fkx for the x-axis. And the idea of opposite still stands, where we will now scale parallel to the same axis, but the scale factor is opposite 1 over k. Alright, so take note of that. Same idea for y-axis. hky equals to gx or ky equals to fx, which can be rewritten as y equals to fx over k, or 1 over k times fx. Similar phrasing, scale parallel to y-axis with scale factor 1 over k. Now for y equals to 1 over k fx, you notice that the scale factor is basically whatever constant you multiply to the fx. So if y equals to 2 fx, scale factor is simply 2. Moving on with reflection, basically if you either reflect about the y-axis or the x-axis. If you can reflect about the x-axis, you can think of it this way. Your value becomes positive y becomes negative y becomes positive y. As such, you get h minus y or minus y equals to fx. Alright, so that's basically the idea how you should look at it. And the same idea is kind of applied when we talk about reflecting about the y-axis. Your positive x will go over to become the negative x. Your negative x would go over to become the positive x, as seen here. As such, it's just simply hy equals to g minus x or y equals to f minus x. Continuing with modulus, we have g mod x or g minus mod x. Basically, look at the input. Mod x will only give you positive inputs. Negative mod x will give you negative inputs only. So that means for either x, will only give you the positive input values. Therefore, for g mod x, we keep the positive x side and then we reflect about the y-axis as well. Similar logic, we keep the negative input and then reflect about the y-axis as well. Similar idea for h mod y or y equals to mod fx. Now, all positive y values are obtained. That means any negative y values that we had will now become positive, and positive values will remain as positive. So those negative y values will then be reflected about the x-axis. Similar for h minus mod y or y equals to minus mod fx, only negative values obtained. Therefore, any positive y values will then reflect about the x-axis to become negative. Negative values will just remain the same. Next up, we have reciprocal graphs. Basically, a comma b becomes a comma 1 over b. If you have a portion of the graph that was increasing, it is now decreasing, and vice versa. On that note, if we have minimum or maximum points, it becomes maximum or a minimum point. X-intercepts becomes x-asymptotes. X-asymptotes then become x-intercept. So the idea of opposite really carries on throughout the chapter. Talking about asymptotes with horizontal asymptote, two types. If we have the first type y equals to b and y equals to 0, the first one still becomes a horizontal asymptote, but it's now y equals to 1 over b. Second type y equals to 0, two possibilities, y approaching plus minus infinity, or becomes an oblique asymptote. Alright, usually that won't really come out. Oblique asymptotes, because your graph approaches infinity, you now have a horizontal asymptote at y approaching 0 or y equals to 0. Same idea, fx approaching infinity, you have a horizontal asymptote of y equals to 0 as well. Lastly, we have the derivative graph. Essentially, is how does the value of the gradient change over the variable? Right, at this point, is it negative? At that point, is it 0 if it's, let's say, a turning point, or is that point positive? After you've figured those out, the last thing you ask yourself is, how is this value changing? Is your gradient getting steeper and steeper, hence more positive? Or is it getting less negative, less positive, or more negative? Or is it suddenly changes to 0? Alright, so do take note of that. X-intercept basically doesn't say anything, all right? It is only the turning point that tells you that, hey, the gradient is 0. Finally, we have combinations. So one threshold part is y equals to fx, 2 y equals to hx. And we'll follow these guidelines for these sorts of equations where we have a, m, and a. The first a and m is for x, second m and a is for y. A for add, m for multiply, so translation then scale. Essentially, first step, translate x, then scale x. Afterwards, scale y, then translate y. Alright, so that's the framework for y equals to fx. Generally, if you want to scale and then translate, the translation will be affected by the scale regardless of the graph you sketch. So it can be y equals to fx or hy equals to gx, alright? It is just universal as shown right here. However, if you were to translate and then scale, your translation would not be affected by the scaling as shown right here.